Welcome to the Test 1 Study Guide review. I just wanted to take some time and go through some of the tricky parts to this study guide. You'll notice at the top it says Spring 2020, but we are in fact in Fall 2020, so don't let that confuse you. I highly recommend everyone complete this or at least look through this. There are many questions throughout this guide. You can see this is 23 pages of fun and excitement. If you answer every question and turn this in, you get 10 points. The answers don't even have to be correct. They have to be at least somewhat valid. You can't answer 0 for every question. And I have some discretion to determine whether you actually attempted the question or not. Why wouldn't you do this? This is helping you prep for the test. It's getting you 10 points for the actual test. And you can pinpoint some of the weaker areas that you may have in the. So let's take a look at some of these things. So there is some questions on binary, hexadecimal, and decimal conversions. I'm not really going to spend time on this. This is something you should have learned in your previous courses. There are some questions. I think one of the hardest parts about this study guide, I didn't make the original study guide, but I've modified it accordingly. Finding the question sometimes is hard within this document. So take your time with it and make sure that, when they're asking you a question, that you answer it. Some of them can be kind of hidden, so just, as I said, take your time, make sure you got everything answered, and that'll be 10 points. I think this section right here, taught this class now, this will be my third semester. Every semester, this gives people problems. I think it's just wrapping your head around what they're asking you. They're asking you, what's the scale of 2 to the 15th? The answer is 32k. Well, how the heck did I get 32k, and what does that mean? Well, the explanation says, 2 to the 15th equals 2 to the 5th times 2 to the 10th. Notice that 2 to the 5th is 32, and 2 to the 10th is k. That is still confusing to me, so maybe this will help. I want to step through 2 examples that I hope help you kind of grasp what we're looking for here. In this first example, it's asking for what is the scale of 2 to the 15th? And the answer is 32k. So if I look at 2 to the 15th, I've got this chart up here, and I also have this chart down here. So I've rearranged my screen to make it easier for this. To find the scale of 2 to the 15th, what I do is I look at this binary column first, and I see 2 to the 10. Does 2 to the 10 fit into 2 to the 15? Yes. Does 2 to the 20 fit into 2 to the 15? No. What about 2 to the 30? Nope. And of course, 2 to the 40 is not going to fit either. So what I do is I automatically know that 2 to the 10 is going to be used. And I subtract that from 15. 15 minus 10 equals 5. And with exponent math, if you forget this from maybe your high school mathematics courses, but when you multiply like numbers with exponents, you add the exponents together, and that might be a confusing thing for some people. All I do is I look up here at the binary. 2 to the 10 fits in the 2 to the 15. Then what I do is I subtract 10 from 15, and I get 5. So I end up with 2 to the 5th times 2 to the 10. Really, my work is done. So I see 2 to the 10 is up here, and I go over to the scale, and it's the K scale, it's the kilo. Additionally, 2 to the 5th, I don't even know, I don't even have to know the math for this because I have this scale here. So when I go over to 2 to the 5th, I get 32. So now my answer is 32k. What about 2 to the 25th? How does that work? Let's go up to our scale again. 2 to the 10th does fit into 2 to the 25th, but 2 to the 20th fits into 2 to the 25th, and it fits into it much closer. So now I can put 2 to the 20 here, and what am I left over with? Well, 2 to the 5th. So then the answer to this one is we already know 2 to the 5th is 32, so I'm going to put 32 here. Now 2 to the 20th, if I go back up here and I go over to the scale, that will be mega. Let's do one final one, so 2 to the 35th. So we already know, we kind of see what the closest one that fits is, and 2 to the 30th seems to be that. And what's left? So 35 minus 30 is 5, so we put 2 to the 5th here. I go over to this chart, I see it's 32, put 32 here. And now 2 to the 30th, I go back up to this chart, and I see it's giga, so I'll put G. That is all this is. Don't sink too much time into this. Honestly, it's not really that big of a deal. There will be a question on the test, but it's not worth very many points. So just wanted to go through that because I know some people get confused about this one. On page 2, we start talking about Java data types. We go through some of the primitive data types that we can find in Java, and then we start talking about ranges of the data types and why they are the way they are. I recommend reading these questions with the answers. So these are supposed to help you kind of learn the concepts and teach you. It goes through the short type, and then here is where you have to start answering the question. Java int type, why is it minus 2 billion to 2 billion minus 1? Why is the range that way? The big hint I will provide here is 32 bits are in the int type. That has something to do with the answer. That you read these ones before you answer this question here. If you don't understand bits and bytes and binary, this section is probably pretty difficult. You may want to do some pretty in-depth review of these number types and the conversions and things like that. It'll make this section way easier and it'll actually make sense to you. If you have no idea what bits are or why there's 8 bits in a byte, then this is going to prove very difficult and you're not going to be able to fully understand this. On the next page, we have this ASCII table. One of my favorite jokes in an in-person class is to tell people that they have to memorize this entire chart. It usually gets no laughs, but I laugh, and the students often get mad at me for saying they have to memorize this. In all seriousness, you don't have to memorize this chart at all. Just know it exists. One thing you should know probably, just in general, is with ASCII characters, many times we try to find things in alphabetical order or sort things. When you have capitalized letters, those are actually represented in decimal form. They are lower than the lowercase values, so it's sort of counterintuitive. So like a lowercase a represents 97, whereas an uppercase a represents 65. So if you're trying to put stuff in alphabetical order, you could have problems. So what's the solution to that? Well, just convert whatever you're trying to sort into all capitals or all lowercase letters and then sort it that way. But just knowing that is something I think you all should know anyway, but just wanted to reiterate that. This section here is really good. I think this does a really nice job of explaining the compilation process from your hello-world.java to hello-world.class. Again, one more reminder, do not ever submit a .class file because why? Well, that's the bytecode. So when I receive it, it's nothing to me. It's gibberish. It's bytecode. I can't run it. If I have your source code, then I can use my JVM and my compiler and compile your code and run it. Okay, so after all of that introductory material, we get into more of the coding style questions. You will be presented with some code that is incorrect. You'll have to make corrections to it. So this is a good example of being able to recognize an error with the code. The code itself, what we're used to looking for is maybe there's a missing semicolon, maybe there is missing quotation marks, which they probably need quotation marks here. There's a few things wrong with this line as well, but there's also something wrong with the class name itself. And that's where you have to look at everything that is presented to you. So if you have a source code file named welcome.java, what do we know? What does that public class need to be called? Well, it needs to be called welcome. When you're looking at the code, make sure you're accounting for all of the information in the question. On the test, you will need to write small code snippets. You'll have to have an understanding of how to use things like if, else if, and else, and also logical operators like the double ampersand or the double pipes in Boolean expressions. That should be reviewed. That's pretty much universal in C++, Java, other programming languages, so that shouldn't be too big of an issue. The code I'm looking at now, this is great review for the test. You'll see questions like this on the test where there's incorrect code on the left-hand side and you have to place correct code on the right-hand side. If I look at the first one here, I have Boolean x equals 1 with a semicolon. Now, the first thing you might say is, well, Boolean's incorrect. It shouldn't just be bool. And that's one of those crossovers if you're used to C++. In C++, sure, the variables are called bool, but in Java, they're Boolean, and that's a common mistake I make all the time. But what are we actually doing here? We're trying to assign the value of 1 to x, which is of type Boolean, and if we know what Boolean types are, it's either true or false. So in this case, the correct answer would be Boolean x equals true, and that would be the correction. So you would do that for all of these. Down here, what you're doing is based on these assignments, so x is 5, y is 6, z is 10, you're going to look at this if statement. And if statements always look for a true or false value and then proceed or go to the else if or else if it's false. So in this first one, we've got 5 is less than 6, which is true. And we have this double ampersand, which is the and we have 6 is greater than 10, which is false. When we have this logical and, both of these have to be true, so this one would indicate false. So let's take a look at this question here. Write an if statement that increases variable pay by 3% if score is greater than 90. I know it's probably going to be if with parentheses, and we can make assumptions. So in questions like this, we can make assumptions. We don't have to write a whole program. We don't have to declare variables before this if statement. All I care about is that your logic is correct. So we can just pretend that I have a score variable already declared in my imaginary program before this if statement. But if we say if score is greater than 90, so now how do I increase variable pay by 3%? Well, we can pretend we have another variable declared earlier in the program. We could say var pay equals var pay times 1.03, semicolon. And that's it. So you don't have to be crazy and declare these variables before this and make this turn into like 7 lines. Just assume that these things are already declared and then you can use them in your program. The next thing you're going to have to know is you're going to have to know how to use this math.random. This is a good question to figure out and research. In Greenfoot, we also have a get random number. Understanding what this is and how this works will also be important on the test. You should probably expect some questions on object-oriented programming, since that is the whole point of this class. So starting on page 10, we have the 4 principles of OOP. I hope you at least know what they are by now. One of the ways I remember these is I create a little acronym called API. So this is helpful for job interviews and things. When someone asks you the 4 principles, you just remember this acronym here. So abstraction, polymorphism, inheritance, and encapsulation. Polymorphism also has some associated context with it. We've talked about a few of these, but not all of them yet. So don't think you have to know in detail what these are. UML will have to understand just the very top surface level of UML class diagrams. So something like this here, you will be expected to have to produce that on the test. You're not going to have to fill in details or even use the UML program that we've been using for our assignments. You'll just have to, in Microsoft Word, insert something just like this. Really not a big deal, and it's really actually pretty easy. Knowing some of the differences between method overloading versus method overriding is not only important for this test, but it will be important moving on in the class as well. So understanding the distinction, like, is this method overloaded or am I overriding this method? So having an understanding of that will help you for the test. Page 11 is full of great information. If you understand page 11, this will get you a lot of points on the test. This page is excellent review, and it summarizes a lot of the key concepts of what we've been learning and that will be asked on the test. Make sure you go over page 11, understand it, and can be able to explain some of these concepts. Page 12 is also one of those sections that students have a hard time with, and it's because it's not very intuitive. You have to kind of work at this to understand it. But one of the handouts we have from chapter 3, I believe, is the memory management for object. Is very confusing, and normally in class I spend a lot of time on it. We will go over this memory management again when we talk about arrays in Java, and that's where I kind of go into detail about it. For now, though, it's good to have a cursory knowledge of the stack and the heap and what that all means and how it works and things like that. We will get into more details about it, but for now, knowing the high-level details is pretty good. So let's take a look at one of the questions that's going to be on the test. It's going to be similar to this, and it's actually going to be much easier than this question. The first thing we have to do is understand what it's wanting us to illustrate. So it's wanting a simple graph showing the methods in the stack for each of the checkpoints. So there's a whole bunch of checkpoints listed down here. There is a description of what's happening in the program. So main calls M1, then calls M2, M1 calls M3, M2 and M3 do not call any other method. This here corresponds to the code down here. So you see, if we look at this one, main calls M1, then calls M2. Here's main. At first it calls M1. So after I call M1, I actually go to M1 here and I do some code. Eventually I go to M3. So M3, then I go over here. I execute some code here. M3 completes. So where it completes, I then pick up back in M1. M1 completes. I go back into main, and now I'm in M2. So now I hop over to M2, execute some code. This ends. Then I go back over to main, and I do some more code here. These periods are just representing some code is happening here. But understanding the program flow and how these things are kind of moving back and forth is important to understanding what is on the stack and when it's, popped off the stack or when it's pushed onto the stack. So here is a graph for checkpoint number 3. So if I go up to checkpoint number 3, let's see what this one is. It says after M1 calls M3, M3 is not finished yet. So what will the program look like in memory on the stack? So we know that we were in main, we went to M1, we popped over here to M1, and we went to M3, and now we're currently in M3 somewhere. So what does that look like? Well, we know we put main on first, so main is always running. Main is going to be at the bottom of the stack, always, unless it's the end of the program or the program hasn't even started yet. Then the first method that we encountered was M1. So then M1 gets pushed on top of main. So M1 is currently running. And then from M1 over here, M3 occurs. So now we're on M3, which means M3 gets pushed onto the stack. When M3 completes, we pop this off. So M3 will pop off. So then we'll just be left with, delete this, we'll just be left with M1 and main. So now we're in M1. We're continuing to execute code here. So now M1 completes. So M1 goes away. And now we're left in main right before M2 starts executing. As soon as we hit M2, then guess what? M2 gets pushed on. So now we're over here. We're executing code. M2 is done. So now we take M2 out. We're back in main. Main is running, so it's the only thing on the stack. Well, there's other stuff on the stack, but this is the only method running on the stack. And then as soon as main is done, then main gets taken away, and we're empty, and then eventually this goes away altogether because the program is over. You'll have to do something like this on the test. Like I said, the test example was way easier than this one. So if you can follow this, or at least follow what I did, you're going to be more than good. All right, again, you'll have some questions that are wanting you to correct some code. There'll be a couple errors in here, but one of the things that jumps out at me right away is I'm returning a value here, but I see a void here. So this would probably be, I would assume, a double, since we're talking about hours and pay rates, because your pay rate is not going to be an integer number. And that leads me down into here, which I probably have to update this as well. So just be aware, if you make a change in one place, it may affect other places you'll have to update. And there's some other things wrong over here that you'll have to correct. So I think page 18 does a really nice job of explaining object creation and methods and how to use them and call them correctly. You're going to be asked to create some programs, some full programs that create objects and assign things to them. This would be a nice thing to review so you fully understand what you're doing, because I think at this point, there may be a lot of you who are able to get the code completed, but might not fully understand what's happening or why you're doing certain things. I think this page will help you understand that. So when you're coding, you're understanding what you're actually doing and why. Test 1 will have 2 questions that will require you to code up answers based on certain requirements presented. This test study guide has excellent review. these questions, you should definitely try in Eclipse and try to make them work and try to understand what they're asking for and why. If you have questions where you want me to look at your code, I can definitely do that. Just send that to me in an email and I'll be happy to review it and provide, say, well, on line 22, this is incorrect and here's why, or this is what they're really looking for. That would help you for the test, and I'm very, very happy to provide feedback. You're freely allowed to use Eclipse or whatever other IDE you want to code up your solutions to these questions. So on the exam, spell out you can use Eclipse to test and run your program, so that is a huge benefit. There will be 2 mandatory coding questions. This study guide was from spring of last semester, where it had 1 coding question that was mandatory, and then there was another bonus question. We have since moved to 2 mandatory questions. You'll have to do 2 coding assignments. The first coding question that you're going to be asked to do is pretty straightforward. It's going to be a single class, so there's only going to be 1 file. The main method is going to be in that class, and there's also going to be an additional method in that class. So here's my example class. I put comments here. So there's going to be a main method. You're going to have some code that does some sort of basic calculation on something and formats the output. Now the code that calculates something will likely be a call to an additional method. So you're going to have a public class example, you're going to have the main method, and you're going to have an additional method in the same class. I'm not going to go through all of the specifics with that. You should be able to handle that no problem. If you have questions about this or you have no idea what I'm talking about, you're like, what's this additional method? Feel free to email me or reach out before the test. I don't want anyone to be confused, but this one should be pretty straightforward and easy. Coding question 2 is just like the homeworks we've been doing, where we'll have a class. In this example, it's hospital patient. And then we'll have another class that contains the main method that creates objects of the hospital patient and does some manipulation to it. So you have instance variables and effectors. So some of my instance variables for hospital patient will probably be patient name, patient room. It's up to you what you want to do. Effectors might be calculate hospital stay, really anything you want to come up with. And then what you're going to do is create the hospital patient class that takes all of these things and codes them up. And also, add the constructors and the getters and setters. After you create that class, this is just like the homeworks, just like homework 3, homework 4, then you'll create some sort of hospital patient runner class where you'll have a main method, you'll create some objects, and then you'll, call some of the effectors on the objects. So that one's really up to you. If you can do all of that, I just went through a cursory review of the study guide, but really spend some time on this study guide. If you know the study guide, the test should be super easy if you review this. If you don't review the study guide, the test will be extremely hard. And like I said, if you fill out some of the questions and you're not 100%, please send me some of your code. Say, hey, can you review this? I would be more than happy to help you out in that regard. Additionally, when you complete all of the questions in this study guide, you get 10 points on the test. And like I said before, the study guide is the best possible review you can do for this test. That's all I have for now. Good luck on the test. You're all going to do amazing, and I wish you the best of luck.